Okay, in this question, we are given the following data about drivers. So we have male drivers and female drivers, and also we have those who have age below 21 and those who have age 21 or above. Okay, so let's first complete this table by putting the totals. The total males, if you add 435 and 240, you will get 675. The total number of females will be 373. Now, the total number of age below 21, you will be adding this and this together, and so you will get 648. And if you add the ages 21 or above, 240 plus 160, you'll get 400. This was 3. Yeah, and then the total number of people in this in the data that is given, you can add either the totals of the last column or the totals of the last row. You should get the same answer, that is 1048. This is the total number of people. Now, before we continue solving, let us give names for the events. So for male, I will use M. For female, I will use F. For age below 21, let's use B, meaning below 21. And if the age is 21 or above, let's say A, meaning above 21. Now the question is, a driver is selected at random. What is the probability that? And then we have 5 sub-questions. We're going to solve them one by one. Just remember, before I go to the next page, that again, we use M for the event male, and we have 675 total males. F will mean female, and we have 373 total females. A will mean age above 21, and we have 400 people whose age is above 21. And last B is the event ages below 21, and we have 648 drivers. So now let's go to the first question. You have the table again, of course, to make it easier for you to solve the question. We want now the probability that it's a male or of age below 21. So this means that I want to solve probability of male M, or this is how we use the symbol for or, like a union, or age below 21. We used B for below. So now this is an or probability, so you have to add the probabilities of male plus probability of age below 21, and you ask yourself now, do we have males whose age is below 21? So do we have a male and age below 21? Yes, and you can see that we have it here. Those are the males and age below 21. Because of this, these events are not mutually exclusive, so we have to subtract the probability of the intersection. So probability of M and B. Probability of male now. What is probability of male? You ask, how many males do we have? We have 675 males. Out of how many people? We have 1,048 people. So you would say this is 675 divided by 1,048 plus. Now, sorry, let's see the second one, plus probability of age below 21. So how many do we have whose age is below 21? The total is 648. Out of how many people? Out of 1,048. So you would put here 648 divided by 1048 total, minus, and now we look at the last one, probability of male and age below 21. So that would be this here. This number is the male and age below 21. So it's M and B together. So this is 435 divided by the total number of people, which is 1048. And if you do this calculation, you will get approximately, so let me instead put it like this, approximately, you write it like this, 0.85, meaning 85% approximately. Okay, so let's go to the next question. Now we want the probability of a female, or, so you put the or here, age 21 or above. We use an A for above 21, if you remember. So since it's an or probability, it will be probability of female plus probability of age above 21 minus the probability of female and age above 21. Notice that we have females whose age is above 21, which is this number here. So this means that this probability, there is a probability here. It's not zero, because they are not independent. There is an intersection. So now let's do them one by one. Probability of female, first, you see that we have 373 females out of the total, which is 1048. So you write here 373 females out of the total 1048, plus, now you ask probability of age above 21. Now above 21 we have 400 people out of 1048. So you'll put 400 out of 1048 minus, and last one is female and age above 21. And we saw that this number here is the number of female and age above 21. So we divide this number by the total number of people. So it will be 160 divided by 1048. And if you do everything correctly, again, it's an approximation, of course, on your calculator, you should get about 0.58 or 58%. Okay, so let's go to the next one. In this one, we want the probability that we have a male, given that, so whenever you see given that, it's a conditional probability. Given that what? The driver is of age below 21. So how do you write this? You'd say, I want the probability of a male, given that, you put this vertical line to say given that, the driver is of age below 21, and we said that we use B for below 21. So this is how you write it mathematically. And for doing so, to solve this, you look at how many drivers have age below 21. We have 648 drivers. So actually, whenever you have something given, you ignore everything except the row or column that contains it. So now we're looking at the row that contains all the ages below 21. Why? Because that is what is given. We are given that the age is below 21. So we just look here and we answer the question easily. How many of the ones that you see here are male? We have 435 out of those 648. So you would say this is 435 males divided by the total number of people with age below 21, that is 648. And if you compute this on your calculator, approximately you'll get 0.67 or 67%. The next one is probability of female and of age 21 or above. Above, we said that we'll call this event A. So probability of female and age above 21, you can look. How many females do we have whose age is above 21? We have 160. There is no conditional probability here in this one, F and A, like this. So we have 160. This means it's a female and the age is above 21. Together will give you this number. Out of how many people do we have? We have 1,048 people. So you'd say this is 160 divided by 1,048. And this is approximately 0.15, which is 15%. Now, this is one way to solve it. I'm going to say that this is one way. If you understood it, it's okay. But also look at another way. There are two more ways actually to solve it. I'll do one of them. You can also use the formula for probability of the and, F and A. Probability of F and A is, if you remember, it's probability of F times multiplication, probability of A given F. Because here there is the fact that a female is chosen. If you choose a female already, it affects the age above 21. So let's see what we get here. Probability of female, again, let me first erase this stuff here. So probability of female is 373 total females out of the total number of people. So this will be 373 out of 1,048. Okay? And now times the probability of above the age of 21 given that it's a female. So once you are given that it's a female, you only look at the column or row that contains this data. So you're looking at the females here because that's what's given. So once it's given, you look only at its row or column. In this case, females are written in a column. So now, in this column, how many of them are above 21? You will see that there are 160 out of the total number of females, which is 373. So you can write here, this is times 160 divided by 373. And if you know simple algebra, you know that this number will cancel with this number because we are multiplying. And look at what you'll get. You'll get 160 out of 1,048, which agrees with the number that we got before, the number that we just got for the first way that I did it, which is approximately 0.15 or 15%. If you want to see the last way to do it, you can do it as probability of above and female, above 21 and female. This is the same, of course, it's the same as this, it's the same as this. When you do and, it doesn't matter which one you put first. So this is the probability of age above 21 times the probability of female given that the age is above 21. And so here, let's first erase the stuff and look at this. Probability of age above 21, we have 400 out of the total 1,048. So this will be 400 above 21 out of the total number of people is 1,048 times. Now, this second one, we are asking what's the probability of a female if you know that, or given that, the age is above 21. So this means that your the row that you're looking at now is the one that is age above 21. This one is the one that is given here. Because it's given, you only concentrate on it and see how many females do we have in this. We have 160 females, and you divide it by the total number of people whose age is above 21. So you will multiply by 160 out of 400. And again, you see that because we're multiplying, this 400 cancels this 400, and you will get 160 out of 1048, which is again approximately 0.15 or 15%. So you choose whichever way is more convenient for you. I believe that the first way, because it's a table, it's given in a table form, it's the easiest one. But you can use the other two, and it makes you understand also the AND probability and the conditional probability at the same time. Okay, now we go to the last question, which is what is the probability that the age is above 21 given that the driver is female? Okay, we already solved it actually on the previous page. It was solved here. Probability of age above given that it's a female. But I will do it again. So when you have given, always look at what's given. You are given female, so only you look at the column that contains the female. And how many of them are above 21? It's 160 out of the total number of females. So this will be 160 out of 373, which is approximately 0.43 or 43%. I will give you just one more question. Suppose that we have an F question which says, what's the probability of, let's say, male given that the age is below 21? So let's see how to solve this. For this one, first let us erase this part and look again. What we are given here is that the age is below. See, below. So you are going to look only at the row that has the below 21. And what's the probability that it's a male in this row? We have 435 males out of the 648 total people whose age is below 21. And so the answer will be 435 divided by 648. And if you use your calculator, this is approximately 0.67 or 67%. I hope that by now you understand how to use tables and how to find the or, the and, the conditional probabilities, and try of thinking of all possible situations, not just the ones that are listed here. You can create your own question from this table. Okay, and that would be the end of this solution.